Okay, let's pick up where we left off here. We match moved the stadium, and we sorted out the scale and the ground plane. So if we go look into 3D space here, again that's a tab to switch between 3D and 2D. And if you hold down the command key and left click, you can orbit. You can see our stadium's point cloud here. You may have tracked this with a bit of a denser point cloud than I did, but this will be sufficient. And then we have our camera here up in the sky moving as we would expect. So what we want to do is we want to go ahead and set up a projection, and let's go ahead and try to project like a big hole on the side of this. So I went ahead and found this big hole picture on the internet. So let's go ahead and prep this to be projected onto the side. So the first thing we want to do is we want to cut it out of this picture. So I created a roto shape to do that. Here it is. So you'll want to go ahead and attach your roto, draw it out, and then pre-multiply it by the RGBA channels, and that'll go ahead and cut it right out for you. And then to cut out the hole on the inside, I've drawn another roto that I drew here, and you'll want to, there's a number of ways to do this. We'll go ahead and create a merge node, and instead of using an over, see, the over doesn't actually cut out the alpha, it just puts black in. I'm going to go ahead and use a stencil and actually physically cut that out. Now you can see when I switch to the alpha channel, we have a physical cutout hole there. Okay, so let's go ahead and project this hole onto the side of the stadium here. So to begin with, let's go ahead and place the hole where we want it. So let's start by creating a corner pin node. You could also do this probably with a transform. I think a corner pin is probably the easiest. So let's go ahead from set, make sure it's set to the input size of this hole here, and then copy from, so that puts our points there. So our points are on the corners, and let's go ahead and merge this over this. So now we have a big hole here, and let's go ahead and try to place this in the proper perspective. So let's move these points down here, and where's this top point? There it is, right there. So here's our where our big hole is going to be. Okay, so let's go ahead and do something like that. Now, that's just for reference. What we're going to need to do next is open the camera tracker, and let's create another camera. Oops. So we create another camera, and we're going to go ahead and make it blue. So just click on this box here and color it blue. You can drag that over to this box, which is the color it's going to display in 3D space, and that's simply to indicate visually that it's a projection camera. It's just a visual indication. The color does not make it a projection camera, just to be clear. So next we're going to want to again look through the camera tracker node, and we're going to want to find a point on this face. So let's go ahead and use this one. It's right on the wall. So let's right click on that, and let's create a card. And it's going to create a card and place its pivot point, its pivot axis right over that location in 3D space. So let's close the camera tracker for now until we need it again. Let's go ahead and plug the card into the scene. So now in the scene we have our point cloud here, and we have our card, and we have our camera. So when we look through the scene, it switches to 3D space, and we should be able to see our point cloud, our camera, and our card. And where is our card? Well, if you remember from the previous class, when we created the scale for the scene, it's a large scene, so the card is quite small. And if we go ahead and enlarge the card to a scale of 100, then it appears. And it appears to be right on our wall, but it's not quite at the right location. So if you hold down Command, we can rotate it. Of course, you can always rotate it here by using the Option key or the middle click. And let's go ahead and just rotate it and line it up with this point cloud here. This is, I'm assuming, the top of the stadium. And maybe it's just a hair back like that. Maybe a hair more. So one of the most important things in projection is the location of the card needs to be pretty dead on for everything to work right. So, you know, that's a bit of art to just get it into the right space. It just takes practice. Certainly connecting it to this point on the camera tracker node helps. So now we have our projection camera, and we have the screen that we need to project this image onto. So let's go ahead and create a project 3D node. So there we go, project 3D, and that's of course located in the 3D shaders menu down here. So there it is. So oops, created another one. Let's go ahead and delete that. So let's connect the camera to the camera and the input to the image here, and then it outputs onto the card. So this image is being projected down through this pipe into this node. It's being projected through this camera onto this card. And if we look in 3D space, there it is, right on the edge. So let's go back to our reference material here, and it's right there. It's right on the edge of this card. So let's go ahead, let's go look in 3D space now, and let's go just move this card over a little bit, like right there. Okay, there we go, right in the middle. So now if we look and see what's going on, and we put the output of the scanline render over this, we ought to see everything working right. Okay, not working right. It's up here instead of down here. So what's going on? Okay, the output is 1920 by 1080. That is correct. It's getting the background information from, if you hit S, you'll bring up the project settings. It's getting that from the full-size format. So that's correct. But what's going on with this? If we look back here at the corner pin and just press 1 to connect that viewer, we can see that the image is actually defaulting to the size of this image, which is 1024 by 734. Now when we placed it over this image, so A over B, we can see, boom, it's a 1920 by 1080 image. So what we can do here is let's move this up, and let's go ahead and create because what we don't want to do is we don't want to just connect it like this, because then as we move forward, see, as we move forward, this doesn't move, but the image does. It's definitely not what we want. So let's go back to this frame. Another thing is we need to frame hold this camera, but we'll cross that bridge in a sec. So let's go ahead and create a constant node, just a black constant, and let's just place this over the black constant. And now if we look, our alpha channel is preserved, and it's passing this 1920 by 1080 image through our projection camera. So if we grab a merge node again and merge the output of the scanline render, which is this projection, over the stadium, and go back to the RGB view, we see exactly what we would expect. And it looks like it's being cut off by the card a little bit, so let's move the card back into position there. Okay, there we go. And let's uncheck image aspect. So, okay, so there we go. Let me take one more look in 3D space and make sure everything looks good. Yeah, let's go ahead and move this card over again. Okay, there we go. And continually refining the location of that card. So there we have that, and we have this output here. Okay, let's disconnect this point cloud for a moment. Now we want to be able to see through this. We want a hole there, so what we need to do is we need to pass this roto, which, if you recall, is the inside hole, stenciling that out. We want to pass that down and out the bottom of the scanline render node as a mask. So let's go ahead and grab and take this roto, the alpha from this roto, and let's create a copy node. And let's go ahead and copy this alpha. So the A is connected, A for alpha. We're going to go ahead and copy this into hole.mat, but you don't have hole.mat, so you will create a new channel, and we'll call it something different. Let's call it damage.mat. So you could call it anything. You could call it bob.smith. You could call it dog.cat, as long as it's one word or symbol with a period and another word or symbol. So that's the procedure for creating a new channel. So damage.mat, we'll hit OK, and it's going to ask us create a new layer called damage, yes, and there it is. So now it's being passed into that layer. And so now if we look up here, if we connect it to this stencil and we look at our list of channels, it's got RGBA, and we can look at the RGB or just the alpha or all three of them. Okay? Now, if we move one node down where we just copied that in and look at the list of channels, you can now see that this appears in this list because this channel is being copied in to this pipe right here. Now, so again, it's in the list. Now, if we go down to here, it's no longer in the list. What's going on? If you recall, the channels other than the RGBA channels are passed through the B pipe. So all the channels, all the RGB channels are being merged together and passed through this. If we look at the parameters, we can see the A has got RGBA and the B has got RGBA, and it's outputting the RGBA. If there was another channel in this, it would also be passing through the B pipe because things pass through the B pipe. So what we need to do is also merge this channel. Now, still looking through merge 6, if we look at the list now, it's being merged. Another way to look at that is to create a shuffle node. And if we look here, we can shuffle this into the RGBA, and there's our hole, right? Here it is corner pinned, and there it is over that. Now if we open this and say none, it's gone. So if we merge it, now it's being passed through the merge node, and then if we go back down all the way to the bottom of the output of the scanline render, we can see there it is, just like we would expect. So this is the hole in the inside of the hole, as it were. Okay, so let's just keep that around for utility. Next, let's go ahead and move this stadium off to the side like this. and let's merge A over B. So let's go ahead and take the B side from here and draw out a dot node like so, and merge A over B. So now we have our hole over our stadium, and if we look at our shuffle node, which we'll just call this the channel damage check, just so we know what this node is doing, we'll just put a little note in there, damage check, okay. So now if we put that on, we can see nothing, because again, the channels are being passed through the B pipe. So we need to go in here and we need to go also merge damage. Now it's there. So what's next? Let me just grab this here. Next, let's go ahead and, well, let's look and see in the RGB again, or above this shuffle node. Let me just take that off. Okay. So now let's look and see what our projection looks like. Okay. Not good. Not good. What's going on? Okay. What's going on is that the projection camera is moving, and so is the camera that's photographing it. What needs to be happening is this camera needs to be frame held. So if we hit tab and type frame hold, we can now frame hold this on frame, say 10, where the playhead is at. Now this camera is frozen on frame 10. So if we go look in 3D land here, we can see, we can reconnect the point cloud, so we can now see that the projection camera and the photographing camera are in the same place right now. So as we advance in time or backwards in time, you can see the photographing camera is moving. It's photographing this projection from different angles, which is then, you know, changing its perspective, obviously, or maybe not obviously, but it's changing its perspective so that it looks correct from the angle it's at. So now if we go and look at this frame here, so we can see that it's changing its perspective. So let's go, let me just go back to frame 10. And I just want to, I'm just going to select all these corner pins. I'm just going to refine its location just a little bit. Something like right there, I kind of like that. Now you can see, okay. So another thing is that it's slightly curved. So we could use the deformation, the bicubic deformation, to deform this card a little bit by moving these points, but we're going to skip that step for now. Okay, so next let's go ahead and copy the 3D scene like so. Make a copy of it down here, and let's also go ahead and copy the projection setup. Copy those nodes, place them down here. Delete this merge, we don't need this. We might need that. Now let's go ahead and take this projection. So this we're going to project, we're creating another projection, and we're going to project this bit here to be like the interior of the building that you can see in the hole. So let's go ahead and create like a, let's put a transform on there. T for transform. Let's put a corner pin on there. And let's go ahead and put a color correct on there as well, because we'll end up color correcting it too. So there's that. Here's a corner pin and a transform. So let's look in 3D space now and open up this card parameters. And we'll go ahead and let's look at the point cloud real quick. And let's rotate around. And the cards parameters, okay. Let's just go ahead and move this back just a hair, like so. And we're probably going to have to do the same trick we did here with the constant, because I want to use this corner pin in this transform to kind of line this up. So let's go ahead and look through this. Let's close the merge for now. Let's close the transform as well. And let's start bringing in these points here. So let's put that at the top. Let's put that there. And that one there. And let's bring this one way in here. So now, okay. So let's say that this is like the inside of our stadium. You know. You can try to bring these up a little bit like this. So we can try to do something a little bit like that, just you know, to give it some interest in there. So what we'll do is we'll take a merge node now. We'll merge this projection, which actually this is frame hold on frame 10. So we should be doing this on frame 10, right? Okay. So that'll be fine. Let's make a constant now. So let's get a black constant and put this A over B, which is now being projected down. And it's right there. So now if we tell it to use this matte channel, now you can see it's only visible through the matte. And remember now, we just created that matte from this roto that we used to cut out the hole, and then we put it in there as this new channel called damage, and we put this in the wrong node. That's the shuffle. So that hole is corner pinned, and then it's being projected through here, and then being passed into this B channel where we're able to use it as a matte way down here. So you know, we could actually do the color correction on this node. We could also color correct it all the way down here. And if we go here and unpremult by RGBA, so it doesn't affect any alpha channels, and then we use this as the mask, we could then in fact color correct this down here based on that matte. So let's go ahead and do that. Let's take the shadow density down just a hair, like so that it kind of feels like it matches this. And let's take the midtones, take the midtones down quite a bit too, like so. There's probably nothing in the highlights, but we could actually just push the highlights over a little bit like that, and then give them just a little bit of a bump so that it has some interest. So there we go. We can color correct the inside of that. Now, additionally, I think we can move this transform here. you know, we'll just fuss around with that a little bit. You can obviously do a better placement job or find better better guts for your thing than I did. Let's go ahead and let's go above everything right here, and let's drop a grade node in here. And let's select the white point right here. So Command Shift, we'll just select this as the white point. Command Option Shift maybe. There we go. And now let's go gain. Command Shift this blue color. There we go. So now we've kind of matched that tonality of that to that of the, you know, the stadium here. We could even maybe try to fade it a little bit. Nah, that's not really going to work for us. Maybe just a hair. Nah. You know, you can play with this. The purpose of this isn't really to work on the color matching, but just set up two simple projections here. So we're projecting the inside of the stadium, and we're projecting the outside hole. And if we go ahead and play that through, you can see that it's sticking right to the stadium, and you have a little bit of parallax as this card is located slightly behind the location of the hole, as you know, you would expect from the guts of this stadium. So there it is, projected in there. Maybe a little too far back. You can again adjust the location of this card in Z, moving it up just a hair. Again, the location of your cards dictates how well things feel like they're sticking. You can also generate a dense point cloud to have a better idea of where everything is. But you know, that is how to set up a projection camera in Nuke.